Hi, do you want to learn video game development? Do you have a nostalgia for classic era video games? If so, this is the right video for you, because we're going to be learning video game development from the ground up by coding out one of the greatest classics of all time, The Legend of Zelda from the NES. In this video, we will not be using any third-party libraries, and we're going to code everything from scratch by ourselves. I'm Jake, and welcome to my channel, Power Up Programming. We'll be programming out The Legend of Zelda in JavaScript using the object-oriented paradigm as our pattern for development. In this code-along video, I will be explaining in depth what it is that I'm doing, so you can follow along and understand as we go. My goal for this video is by the end of it, you should feel confident enough to take your new knowledge and finish programming out either this game or to begin programming out your own video game. Now, I want to be clear that this video is an intro to video game development, not to JavaScript or OOP. It would be good if you were already a little knowledgeable in JavaScript and how OOP works, so you can understand everything it is that I'll be doing. I will be explaining as I go, but that foundation of knowledge will really help you a lot. Now, our overall architecture for programming out this video game will be the ECS architecture. It's a very well-known design architecture for video games. It's used by video game engines like Unity. If you don't know it already, though, that's okay. You don't need to know. But by the end of it, you will have a very strong understanding of how to program a video game using this design architecture. It's a very powerful design architecture, and for that reason, Unity uses it. I've made some slight modifications to the patterns in order to streamline your experience in this video. This video will be broken up into 13 parts. This is a long video, so if you ever get lost along the way, you can pull down the code from the beginning of each one of the parts in the public GitHub repo I've linked in the description. And before you begin, please pull down the intro folder's code from that public repo, so you have all the assets in the correct folder structure. In this video, we will only be programming out the very beginning of The Legend of Zelda, but with what you learn in this video, you'll easily be able to program out the rest. If you do finish this video and you would like to see me continue to program out The Legend of Zelda or perhaps some other kind of content, please comment, like, subscribe, and click the little bell for notifications. I'm still a really small channel, so every sub that I get means a lot and helps me to build out more content in the future. Thank you, and good luck. Before we begin, please use this live server extension. I suggest that you use Visual Studio Code for this course, although you can use another text editor if that's what you would like to do. I do suggest that you use this one because we will be using the live server extension. It's made by Ritwick Day. It'll allow us to, as it says, launch a development and local server with a live reload feature for static and dynamic pages, meaning we'll be able to serve our game right onto the browser, and it's going to be really easy for us to see changes. To find it, type into the extensions tab live server, and you can click the install button. I already have it installed. However, once you do install it, all you need to do is go to the bottom right hand corner. You can't see it because I'm actually in front of it, but it should say go live in the bottom right hand corner. And then all you have to do is click the button. It'll start, and then it should pop up on your currently preferred browser. Mine is Brave browser, but it should show up on Google Chrome or Safari or whatever browser you have set as your default browser. And that's it. So to begin, please pull down the GitHub repo that I've posted in the description to start off with the correct assets. I'm going to begin by linking index.js to index.html. And in index.js, the first thing we're going to do is we're going to create the game class where a lot of our logic will be happening. And then I'm also going to interact with the index.html through a canvas object. So to begin, let's just create this class game. And this class is going to have 3 primary methods as well as a constructor. So first off, we'll just create the constructor. And it's 3 methods, which will be initialize. We're going to make these arrow functions. Update. And render. And what initialize, update, and render will do are set up the game and then keep the game running. So update will be handling changing the changes in values, such as your position. And then render will be displaying those changes in values onto the screen. But more on that later. What I want to do now is interact with the index.html. So let's go to index.html. And we're going to create a canvas element. If you're not familiar with the HTML canvas element, essentially this canvas element allows us to write on the browser screen. We can draw shapes, we can write text. I'm actually going to get this canvas element. And this canvas element I'm going to get from JavaScript, the JavaScript index.js file. I'm going to put it on the outside of the game class because we're going to have this as a global object. Get element. We're going to get it by tag name canvas. But actually, let's just get element by ID, game screen. We'll add an ID to this just to make sure it's clear, because later on we're going to actually have two canvases, one for the game screen and one for the inventory, but we'll see that later. So const canvas. And now that we have the canvas, and let's just demonstrate this. Now open up your browser of your choosing. I'm going to use the Brave browser just because that's the one I'm accustomed to, but you can use Google Chrome as well. Open up to your port. Okay, so now we're properly getting the canvas, and we can see how big it is too. It's that small section of the screen. Let's make the canvas the full size of the screen. So to do this, we'll just add an inline CSS. So we can do width, whatever you want, 1,000 pixels, height, 1,000 pixels, just to make it a nice square. Boom. Now that we have our canvas set 1,000 pixels in each dimension, how do we draw on it? So JavaScript has something called context, and this is derived from the HTML canvas element. And it will allow us to, as I mentioned before, draw rectangles and fill in text and stuff like that. So I'm going to create this context, and I'm actually going to just call it C because that's the typical pattern developers use. It's short, and we're going to be using it a lot. So instead of writing out the word context every time, it's just easier to do that. And we call this getContext method. This getContext method is built into the canvas object, and we can use 2-dimensional or 3-dimensional. Since our game is going to just be 2D, we'll just type 2D. Let's console log this out just to make sure we have it properly. Context. See? Cool. And now we have a canvas rendering context 2D. So you're going to see here there's a variety of properties that come along with this canvas. You can take a whole course on Canvas and how to create cool images, but I'm just going to show you what we need to have something appear on the screen. So why don't we just keep it really simple, and we will create a rectangle. So how do we do this? So when you begin drawing Canvas, when you're drawing a shape, it always needs to begin with begin path. You need to call this method. It's kind of like picking your pen up off the paper and putting it onto a new place. So we do C begin path, do fill rectangle, and we can put it anywhere on the canvas, but let's just keep it simple. We'll do at the zero value for X and Y, and then we'll make the width 100 by 150 on the canvas. And actually before that, we need to fill style, which will be the color. And finally, we'll do C stroke, which actually puts the pen to the paper and draws what it is that we want. Actually, this fill style is a property. It's not a method. And now let's see. We have our square. Wow, that's really big. Let's change some of the dimensions. Now it's small. Cool. Okay, so now we have our canvas and our context working. And we're going to put this into our game. So our game is going to have a player. This player is going to be Link. So when we create our game, we also want to have this player. So I'm going to actually set this player to undefined. And in the initialize method, we are going to create this player. And we're going to make the player the shape to begin with. We're going to make the player have the properties that move the square. So on initialization, we'll make this player, let's say x is equal to 0, y is equal to 0, height is equal to 50, and then width is equal to, how about 60? And on update, we will want to update this player's position. So let's say the player x, we'll just increase the player's x position by 1, so he moves across the screen. And then on render, we're actually just going to cut this and paste it right here. We're going to take these values and we're going to replace them with the player's values. So const xy with height, player, do a little ES6 property destructuring. Cool. And this is how we're going to move our player across the screen. To begin with, this is very rudimentary, but I just want you guys to get a hang of how context works and how canvas works. So this is going to be the code. And how are we going to make this actually work, right? So since we're working from the OOP paradigm, we're going to instantiate a new game, and then we're going to call each method. And this will become more clear later as to why we're building it exactly like this, but just follow along. Cool. So awesome. We have it appearing, but it's not moving, right? We need to make it move. So what we need to do is we need to call update and render continuously. And how do we do that? Well, we do that by using a very special function that's built right into JavaScript called request animation frame, I believe. Yes, request animation frame. And what this function does is it calls the function that you pass into it asynchronously. And if you put it within the function that you're calling, it'll just continually call. So it's recursion. It continually update gets called once here. It runs this. It increments the player's x by 1. And then request animation frame calls this function again asynchronously. So it's a loop. And we're going to do that right here as well within render. So request animation frame, this render. Beautiful. Up. We see it moving across the screen, but we are noticing now that it actually looks like it's just expanding. And why is that? Well, I actually forgot to mention that upon render, the very first render, we actually want to clear the canvas of any previous images that were on the screen. Because yes, it's drawing new image, but it's not removing the image that was already there. It's not removing the old square. So we actually want to do clear rec, which clears the entire, well, it clears the canvas based on the dimensions you put. So we're going to have it start the clear at x and y 0 with a 1000 width and height clear. And there we go. We see it moving across the screen. It's beautiful. We can also play around with this too. Maybe we want to make the y move as well. Let's see how that looks. Oh, now it's going at an angle. But that's not very fun. We want the players X and Y to move based on what the user inputs into the keyboard, right? So I'm going to show you now how we're going to handle user input to move the player. And to do that, we're going to create another method within our class. So we're going to call this method handle user input. We're going to get rid of this player X and this player Y. We're just going to have update. Now we're going to actually take handle user input and we're going to add an event listener in initialize. So if you're not familiar with event listeners, it is instructing JavaScript to listen to any keyboard events or any kind of mouse events that the user inputs into the browser. To do this, you use the document object and the add event listener method. And the first argument is the event that you want to fire a specific function on. So for us, we're going to want key down, which is one of the events. And then we're going to call the function that we want to use when the user pushes a key down. And this is going to be handle user input. And we're also going to do key up as well, because we're going to be doing things when the user releases a button. So what happens is when this gets called, it actually gets an object passed to it as an argument. And this argument is the event itself. And this argument, or this object I should say, it has two properties in it. Two properties that are relevant to us anyway. So it looks kind of like this: key and type. So the key is also a string as well. Like it's going to be, if you press C, it'll be the letter C. If you press W, it'll be W. For me, when I was playing video games when I was younger on the computer, I feel like a lot of the controls I was using was W for up, A for left, S for down, D for right. I'm going to also use that kind of control scheme for our game too. So let's get these properties. I'm going to just replace this with string so we're clear. Cool. So let's get these properties, key and type, from the event. And since we only want to handle user input if the player is on the screen, let's wrap the following code in a logic structure just to check that the player is defined. This will be useful in the future. The next thing we want to check is the type, because we're listening to two different types. We're listening to key down and we're listening to key up. So let's say if type is equal to key down, and that's the value that pressing the key down will literally have. It'll be a string that just says key down. Do something. So now the next thing we need to do is we're going to do something based on what key is down. Let's actually write a switch in this case, because I just feel like it ends up being a little bit more beautiful when you're writing code to use it in this situation. So if the key, right, is W, let's make this player's Y go up. And I believe it's actually inverse. So I think the closer to 0 you are, the higher you are on the y-axis, and the further away from 0 you are, the lower you are on the x-axis. I believe that's how it works. But we'll see. We'll test it out. This player X, so A and D will handle the x-axis. So I believe if the closer to 0 you are for X, it'll be further to the left the square is, and then the opposite for to the right. The further away you are from 0, the further to the right you are. So case S, oh, let's not forget our breaks. Many times I forget the break and then I'm wondering what's going wrong. Okay, so let's add 1 to Y, and then case D, this player. Perfect, okay. Cool, looks good. And now let's see how this is working. So I'll press D first. It's moving to the right. Now A, S, W. Fantastic. Now I'm going diagonal. And now I'm doing up and down at the same time. It looks like it works.